Deep beneath the ocean's surface lies a pitch-black world where the pressure would crush a human body in seconds. While we've mapped the moon and sent robots to Mars, there are still places right here on Earth that remain completely untouched by human presence. These aren't just hard-to-reach spots. They're virtually impossible to access. Today, we're diving into the 10 most mysterious places on Earth where no human footprint has ever been made. 1. The unexplored depths of the Mariana Trench, beyond Challenger Deep. The Mariana Trench is the deepest known part of Earth's oceans, plunging down to a staggering 36,070 feet below sea level at its deepest point, Challenger Deep. While a handful of explorers have reached Challenger Deep, what most people don't realize is that vast sections of the Mariana Trench remain completely unexplored. The trench stretches for 1,580 miles, with countless mysterious crevices, valleys, and depths where no human has ever ventured. The pressure at these extreme depths is more than 1,000 times what we experience at sea level, enough to crush a human body instantly. Water pressure this intense makes traditional exploration nearly impossible. Even our most advanced submarines and diving equipment can only safely reach certain parts of the trench, leaving the rest shrouded in darkness and mystery. Scientists believe these unexplored areas may contain entirely new ecosystems and species that have evolved in complete isolation from the rest of the planet. Recent remote sampling has discovered microorganisms that can survive in conditions previously thought impossible for life. These extremophiles could revolutionize our understanding of how life adapts and survives. What makes these unexplored depths even more fascinating is that they're closer to us than outer space, yet we know less about them than we do about the surface of Mars. The trench formed when the Pacific Ocean plate subducted beneath the Philippine Sea plate, creating a massive underwater canyon that continues to deepen by about 1 inch per year as the plates shift. The darkness at these depths is absolute. No sunlight penetrates below 3,300 feet, meaning that any exploration requires powerful artificial lighting that only illuminates small sections at a time. This makes comprehensive mapping nearly impossible with current technology. Most of our knowledge about the deepest parts comes from sonar mapping and remote sensors, not direct observation. The water temperature in these unexplored depths hovers just above freezing despite the immense pressure, creating a paradoxical environment that scientists are eager to study. These conditions may preserve ancient marine life forms that have long disappeared from other parts of the ocean, potentially offering glimpses into Earth's distant past. The unexplored regions of the Mariana Trench represent one of Earth's last true frontiers, a place so extreme and inaccessible that it remains beyond human reach. While technology continues to advance, the challenge of exploring these depths remains monumental, requiring innovations that can withstand pressures that would flatten conventional exploration equipment like a tin can. 2. Lake Vostok, a subglacial lake buried beneath Antarctica. Lake Vostok remains one of Earth's most isolated bodies of water, concealed beneath 13,100 feet of ice in the heart of Antarctica. Discovered by Russian scientists in the 1990s using radar, this massive freshwater lake stretches 160 miles long, 30 miles wide, and reaches depths of 3,300 feet, making it one of the largest lakes on Earth. Yet despite its enormous size, no human has ever seen its waters with their own eyes. The lake has been sealed off from the outside world for an estimated 15 to 25 million years, creating what scientists believe is one of the most pristine environments on the planet. The water within Lake Vostok is thought to be incredibly pure, containing oxygen levels 50 times higher than typical freshwater lakes due to the immense pressure from the ice above. This creates conditions unlike anywhere else on Earth. What makes Lake Vostok truly extraordinary is the possibility that it hosts life forms that have evolved in complete isolation for millions of years. Russian scientists have drilled down to the lake's surface and collected water samples that contain microorganisms with DNA unlike anything in our scientific databases. These potential new life forms have adapted to extreme darkness, pressure, cold, and oxygen levels that would be lethal to most known organisms. The temperature within the lake hovers around 27 degrees Fahrenheit, which is below freezing for normal water. However, the enormous pressure from the ice above prevents the water from solidifying, creating a liquid environment in conditions that defy our everyday understanding of physics. The lake itself generates heat through a combination of geothermal activity below and the insulating properties of the massive ice sheet above. Scientists believe that Lake Vostok may resemble the subsurface oceans thought to exist on Jupiter's moon Europa and Saturn's moon Enceladus. This makes the lake not just a scientific curiosity, but potentially a testing ground for techniques that could one day search for extraterrestrial life in our solar system. The challenges of exploring Lake Vostok mirror those we would face investigating these distant worlds. International treaties strictly regulate drilling and exploration of Lake Vostok to prevent contamination of this pristine environment. Current scientific efforts focus on developing absolutely sterile drilling methods that could allow for direct observation without introducing modern microorganisms. The delicate balance between scientific discovery and preservation makes exploration painfully slow and methodical. The buried lake represents one of Earth's most perfect time capsules, a place that has remained unchanged since before humans walked the Earth, while ice cores from above the lake have provided indirect glimpses into its chemistry and potential biology. The vast body of water itself remains unseen by human eyes and will likely remain that way for generations to come as we develop the technology to explore it responsibly. Third, uncharted sections of Son Doong Cave in Vietnam. Son Doong Cave in Vietnam's Phong Nha Ke Bang National Park holds the title of the world's largest cave passage by volume. Discovered in 1991 by a local farmer named Ho Con, the cave wasn't professionally explored until 2009 when British cavers made the first expedition into its enormous chambers. Despite being mapped in recent years, vast sections of Son Doong remain completely unexplored by humans due to their inaccessibility. The main passage of Son Doong stretches more than 3 miles and contains chambers so vast that a Boeing 747 could fly through them comfortably. Inside exists an entire ecosystem complete with jungles, rivers, and unique weather patterns, including fog and clouds that form within the cave itself. But beyond the main passage lie networks of smaller tunnels, underwater channels, and collapsed sections that have never felt a human footstep. What makes exploration so challenging is the cave's complex hydrology. During monsoon season, entire sections of Son Doong fill with raging waters that can rise over 300 feet, making year-round exploration impossible. Several side passages become completely submerged, requiring specialized cave diving equipment and expertise that few possess. The combination of tight passages, underwater sections, and unstable rock formations creates barriers that have kept humans out. Scientists have used remote sensing technology to detect chambers beyond currently accessible routes that may be even larger than the main passage. Ground-penetrating radar suggests the cave system may connect to nearby Hang Thung Cave through passages that are currently blocked by massive boulders or filled with water. These potential connections remain theoretical without direct human exploration. The unexplored sections of Son Doong likely contain mineral formations that have developed undisturbed for millions of years. The cave is already famous for its towering stalagmites and cave pearls the size of baseballs, but geologists believe even more spectacular formations may exist in chambers that remain untouched. Some of these formations could provide valuable information about Vietnam's geological history and ancient climate patterns. Biologists have discovered several new species within Son Doong's explored sections, including unique invertebrates that exist nowhere else on Earth. the unexplored regions potentially harbor even more undiscovered species that have evolved in isolation. The cave's unique microclimate creates conditions where specialized organisms can thrive without any connection to the outside world, making it an evolutionary laboratory sealed within stone. The Vietnamese government strictly limits access to Son Doong to protect its fragile ecosystem, with only a small number of tourists allowed to visit each year with professional guides. Exploration of new passages requires special permits and extensive safety precautions. As technology and caving techniques advance, humans may eventually reach some of these hidden chambers, but many will likely remain untouched and unseen, preserving their mysteries for generations to come. Fourth, superheated magma chambers beneath active volcanoes. Miles beneath the surface of active volcanoes lie magma chambers filled with molten rock, heated to temperatures exceeding 2,000 degrees Fahrenheit. These vast reservoirs of liquid stone power the most destructive natural forces on our planet, yet remain completely inaccessible to direct human exploration. What we know about these chambers comes exclusively from indirect measurements, seismic imaging, and the analysis of erupted materials, never from first-hand observation. The extreme temperatures within these chambers would instantly vaporize any conventional exploration equipment, let alone a human body. Even the most heat-resistant materials created by modern science would fail in seconds under such conditions. The chambers also exist under immense pressure, often equivalent to thousands of atmospheres, which would crush any protective vessel long before it reached its destination. Magma chambers aren't simply pools of uniform molten rock, as often depicted in simplified illustrations. They're complex systems with different zones of varying temperature, chemistry, and crystal content. Some chambers contain partially solidified crystal mush zones, alongside areas of completely liquid magma. This complexity makes them fascinating geological systems that drive everything from volcanic eruptions to the formation of precious mineral deposits. What makes these chambers even more intriguing is their dynamic nature. They're constantly changing, growing, shrinking, and evolving in composition as magma moves through Earth's crust. Some chambers exist for millions of years, slowly cooling and crystallizing, while others form rapidly before major eruptions. This hidden activity beneath our feet shapes the very surface of our planet in ways we're only beginning to understand. Scientists can detect these chambers using techniques like seismic tomography, which measures how earthquake waves travel through different materials. Denser materials transmit waves faster than less dense ones, allowing geologists to create three-dimensional maps of what lies beneath volcanoes. These maps reveal chambers ranging in size from small pockets to massive reservoirs containing enough magma to fill several million Olympic swimming pools. The study of magma chambers goes beyond scientific curiosity. It's crucial for predicting volcanic eruptions and protecting communities living in their shadows. By monitoring changes in these chambers, such as sudden influxes of new magma or increases in pressure, scientists can sometimes predict when a volcano might become dangerous. This makes understanding these inaccessible places a matter of life and death for millions of people worldwide. While humans may never directly visit these infernal regions, robotic probes designed to withstand extreme conditions might someday provide our first glimpse inside active magma chambers. For now, these superheated chambers remain among the most hostile and inaccessible places on our planet. Geological engines powering Earth's most spectacular and destructive natural phenomena from behind an impenetrable veil of rock. 5. The Earth's inner core. At the very center of our planet, approximately 3,958 miles beneath our feet, lies Earth's inner core, a solid sphere of iron and nickel roughly 760 miles in diameter. Despite being literally beneath us at all times, it remains one of the most inaccessible places in our solar system. No human technology can withstand the crushing pressure of 3.6 million atmospheres and temperatures comparable to the surface of the Sun, around 9,800 degrees Fahrenheit, that exist at Earth's center. The inner core exists in a paradoxical state. Despite temperatures hot enough to melt iron under normal conditions, the extreme pressure forces the atoms into a solid crystalline structure. This creates a solid metal ball spinning at the heart of our planet. Remarkably, evidence suggests the inner core rotates slightly faster than the rest of Earth, completing its rotation a fraction of a second faster than the surface world we inhabit. What makes the inner core particularly mysterious is its composition. While primarily iron and nickel, scientists believe it contains other elements in unknown quantities. Recent research suggests it may include significant amounts of silicon, oxygen, sulfur, and potentially even rare elements like gold and platinum. Without direct samples, the exact recipe for Earth's center remains one of geology's greatest unanswered questions. The boundary between the inner and outer core, known as the Lehmann discontinuity, represents one of the most dramatic transitions in our planet. On one side exists the liquid outer core, responsible for generating Earth's magnetic field. On the other, the solid inner core that grows by approximately 1 millimeter annually as the planet slowly cools over geological time. This growth has profound implications for Earth's magnetic field and overall thermal evolution. Everything we know about the inner core comes from studying seismic waves generated by earthquakes. When these waves travel through the planet, they change speed and direction when passing through different materials. By analyzing these changes, scientists can infer properties of Earth's interior without direct observation. Recent evidence suggests the inner core may have an even more complex structure than previously thought, potentially with distinct layers or regions of varying crystalline alignment. The inner core plays a crucial role in making Earth habitable. The heat it releases drives the convection currents in the outer core that generate our planet's magnetic field. This magnetic shield protects us from harmful solar radiation and prevents our atmosphere from being stripped away by the solar wind, a fate that befell Mars when its core cooled. Without the inner core's energy, life as we know it couldn't exist on Earth's surface. While humans will never directly visit Earth's center, our understanding continues to improve through advanced computer modeling and seismic analysis. The study of this inaccessible region teaches us not just about our own planet, but provides insights into the internal structure of other rocky worlds throughout our solar system and beyond. The inner core remains Earth's most remote frontier, closer to us than the moon, yet infinitely less accessible. 6. Remote areas of the Amazon rainforest canopy. High above the jungle floor of the Amazon rainforest exists another world entirely. The uppermost canopy region that rises 160 to 200 feet above ground level. While biologists have studied sections of canopy using cranes, towers, and walkways, vast stretches of the uppermost Amazon canopy remain untouched by human presence. These areas, particularly in the most remote regions of Brazil, Peru, and Colombia, represent one of Earth's least explored terrestrial environments. The inaccessibility of these regions stems from multiple challenges. The extreme height of emergent trees that tower above the main canopy, the fragility of branches that cannot support human weight, and the remote location of pristine forest sections far from any access point. Some canopy areas exist in regions so remote that reaching them would require weeks of difficult travel through dense jungle, only to face the nearly impossible task of ascending to the uppermost branches safely. What makes these unexplored canopy regions so scientifically valuable is their biodiversity. The upper Amazon canopy hosts countless species that never descend to the ground, living their entire lives in this elevated world. Scientists estimate that up to 25% of all rainforest species may live exclusively in the canopy. Recent targeted expeditions have discovered dozens of new insects, plants, and amphibians in accessible sections, suggesting unexplored areas likely harbor numerous species completely unknown to science. The unexplored canopy exists as an ancient, three-dimensional landscape shaped by countless generations of trees competing for sunlight. Some emergent trees are hundreds of years old, creating stable elevated ecosystems that have evolved in isolation. These areas feature complex microclimates with temperature, humidity, and light conditions distinct from the forest below. Morning fog, afternoon heat, and fluctuating moisture levels create environmental conditions that change dramatically with height. Remote sensing technology has revealed that these untouched canopy regions serve as critical carbon sinks, absorbing enormous amounts of atmospheric carbon dioxide. They also generate weather patterns that influence rainfall across South America. Despite their ecological importance, these areas face multiple threats, including climate change, which alters temperature and precipitation patterns, and distant deforestation, which fragments the forest and disrupts ecological connections. What we've learned from accessible canopy areas has revolutionized our understanding of forest ecology. Scientists now recognize that up to 90% of all interactions between insects and flowering plants occur in the canopy. The unexplored regions likely contain crucial information about pollination, seed dispersal, and the complex relationships between species that maintain forest health. These ecological interactions may hold solutions to agricultural challenges and insights into natural pest control. The remote upper canopy represents one of the last frontiers of terrestrial exploration, places that exist in plain sight yet remain beyond human reach. As drone technology and lightweight sensors advance, we may gain new insights into these regions without physical presence. However, the most isolated sections of Amazon canopy will likely remain places where no human has set foot, preserving their mysteries and ecological integrity in an increasingly explored world. 7. Deep-sea hydrothermal vents in the South Pacific. In the crushing darkness of the deep South Pacific Ocean, more than 10,000 feet below the surface, lie hydrothermal vents that have never been visited by humans. These underwater geysers form along mid-ocean ridges where tectonic plates pull apart, allowing seawater to penetrate deep into the Earth's crust. There, it heats to extreme temperatures before erupting back into the ocean, carrying dissolved minerals that build chimney-like structures rising from the seafloor. The most remote of these vent fields exist in regions of the South Pacific that remain largely unmapped. Scientists estimate hundreds, perhaps thousands, of active vent systems exist that have never been observed by human eyes or even remote cameras. The overwhelming majority of the ocean floor remains unexplored, with new vent fields discovered during almost every deep-sea expedition. The remoteness of these locations, combined with the technical challenges of deep-sea exploration, keeps them beyond human reach. What makes these unexplored vents particularly remarkable is their potential to harbor entirely unique life forms. Each known vent field hosts distinct species that exist nowhere else on Earth. These ecosystems don't rely on sunlight for energy, but instead draw life from chemical reactions between the minerals in vent fluid and seawater, a process called chemosynthesis. Specialized bacteria convert toxic compounds like hydrogen sulfide into usable energy, forming the base of these alien food webs. The conditions around these vents are among the most extreme on Earth. Water temperatures can exceed 750 degrees Fahrenheit near the vent openings, but don't boil due to the crushing pressure of the deep ocean. The water contains high concentrations of toxic metals and compounds that would kill most familiar life forms instantly. Yet specialized organisms not only survive, but thrive in these conditions, challenging our understanding of the limits of life on Earth and potentially other worlds. Scientists believe these unexplored vent systems may provide clues about the origin of life itself. The chemical-rich, protected environments around vents offer conditions similar to those of early Earth when life first emerged. Some theories suggest life may have originated in precisely these types of environments before spreading to other parts of the planet. The unexplored vents could contain microorganisms that provide missing links in our understanding of evolution's earliest chapters. Beyond their biological significance, these remote vent fields contain valuable mineral deposits, formed as superheated water laden with dissolved metals cools upon contact with the near-freezing ocean. These deposits contain concentrated amounts of copper, zinc, gold, and rare earth elements used in modern technology. Their potential economic value has sparked interest in deep-sea mining, raising concerns about damaging these unique ecosystems before they're even discovered. The exploration of new vent fields requires specialized deep-sea submersibles capable of withstanding enormous pressure and navigating rugged underwater terrain. Only a handful of nations possess this technology, limiting our ability to study these environments. As exploration technology improves, we may eventually discover some of these hidden vents, but many will likely remain untouched in the vast darkness of the deep ocean. Otherworldly ecosystems existing in parallel with our surface world. The exploration of new vent fields requires specialized deep-sea submersibles capable of withstanding enormous pressure and navigating rugged underwater terrain. Only a handful of nations possess this technology, limiting our ability to study these environments. As exploration technology improves, we may eventually discover some of these hidden vents, but many will likely remain untouched in the vast darkness of the deep ocean. Otherworldly ecosystems existing in parallel with our surface world. 8. Uninhabited islands of the South Sandwich Islands. Scattered across the stormy South Atlantic Ocean, the South Sandwich Islands form a remote volcanic archipelago where several of the smallest, most isolated islands have never felt human footsteps. These uninhabited outposts, particularly the smaller islands like Leskov Island and some offshore rock formations, remain among the few land areas on Earth that humans have never visited. Surrounded by some of the planet's most consistently violent seas and shrouded in fog much of the year, they represent terrestrial isolation in its purest form. What makes these islands so inaccessible is their perfect storm of forbidding characteristics. Many feature near vertical cliffs, rising straight from turbulent seas, with no beaches or landing sites. The surrounding waters are notoriously dangerous, with massive waves, unpredictable currents, and water temperatures hovering just above freezing. The islands sit directly in the path of the Furious 50s, the powerful westerly winds that circle Antarctica unimpeded by land masses, making approach by sea or air extremely dangerous. The geology of these untouched islands tells a story of violent creation. They form part of the Scotia Arc, a curving line of underwater volcanoes marking the boundary between the South American and Scotia tectonic plates. Many remain actively volcanic, with several erupting in recent decades. This ongoing volcanism, combined with constant erosion from the powerful South Atlantic waves, means the islands are continuously changing shape, further complicating any potential landing attempts. Despite their inhospitable nature, these islands teem with life, primarily vast colonies of seabirds and marine mammals that use them as breeding grounds. Hundreds of thousands of penguins, albatrosses, and petrels crowd every available surface during breeding season. The surrounding waters host abundant marine life, drawn to the nutrient-rich upwellings, where cold Antarctic waters meet warmer Atlantic currents. This biological richness exists in stunning contrast to the island's stark, often ash-covered landscapes. The climate of these never-visited islands ranks among Earth's most severe and unpredictable. Temperatures rarely rise above freezing, and sudden storms can develop with little warning. Many islands experience near-constant precipitation, falling as snow, sleet, or freezing rain. Cloud cover is persistent, with some islands seeing fewer than 5 to 10 clear days annually. This combination of elements has effectively sealed these islands off from human presence throughout history. The United Kingdom claims these islands as British overseas territory, with strict regulations protecting their pristine environments. Some larger islands in the chain have hosted temporary scientific research stations, but the most remote outcrops remain untouched except for occasional aerial surveys. Their protected status ensures they'll likely remain uninhabited indefinitely, preserving them as some of the last truly wild places on Earth. What makes these never-visited islands particularly valuable from a scientific perspective is their role as pristine ecological baselines, places completely free from direct human influence. By comparing these untouched ecosystems with similar environments that have experienced human contact, scientists can measure the subtle ways human presence alters natural systems. In an increasingly developed world, such untouched reference points become increasingly rare and valuable. 9. The buried Gamburtsev mountain range in Antarctica. Hidden beneath miles of Antarctic ice lies one of Earth's greatest geographical secrets, the Gamburtsev mountain range, a chain of peaks rivaling the Alps in scale, but completely invisible from the surface. Discovered in 1958 by Soviet scientists using seismic soundings, these mountains stretch for over 750 miles across East Antarctica, with peaks reaching heights of 9,000 feet or more. Despite their massive size, no human has ever seen them directly, as they're buried beneath 2,000 to 15,000 feet of solid ice. What makes the Gamburtsev Mountains particularly mysterious is their very existence. Unlike most major mountain ranges that form along the boundaries of tectonic plates, these peaks sit in the middle of the East Antarctic Craton, a stable, ancient section of continental crust. Their presence defies conventional geological understanding, as mountains in such locations typically erode away over millions of years. Yet these buried peaks remain tall and jagged, suggesting they're either much younger than their surroundings or were somehow preserved from normal erosion processes. Scientists believe these mountains were the birthplace of the East Antarctic ice sheet roughly 34 million years ago. As Earth's climate cooled, snow began accumulating on these peaks, gradually compressing into ice and spreading outward to form what would become the largest ice sheet on the planet. Ice radar imaging reveals ancient river valleys carved into the mountain flanks, suggesting they existed as an exposed range long before being buried under ice. The environment between the ice and mountain peaks creates one of Earth's most unique hydrological systems. The pressure and heat generated by the massive ice sheet causes melting at the base, creating a network of subglacial lakes and rivers that flow around and through the mountain range. These liquid water bodies remain entirely separated from the surface world, potentially hosting microbial ecosystems that have evolved in isolation for millions of years. Accessing the Gamburtsev Mountains directly would require tunneling through miles of ice, a feat beyond current technological capabilities. Our knowledge comes entirely from remote sensing methods, like ice-penetrating radar and seismic surveys that can see through the ice sheet. The most detailed imaging comes from Operation Icebridge, a NASA project that uses specialized aircraft equipped with advanced sensors to map Antarctica's subsurface features. Geologists theorize that studying these mountains could provide crucial insights into ancient Earth. The range may represent fragments of a much older mountain building event, dating back over 1 billion years to the assembly of the supercontinent Rodinia. Their preservation beneath ice has potentially protected geological features erased elsewhere on Earth through weathering and erosion, making them a unique time capsule of Earth's distant past. The buried Gamburtsev Mountains represent one of exploration's ultimate paradoxes, a massive geographical feature that, despite being thoroughly mapped and studied, remains completely inaccessible to direct human observation. As climate change threatens Antarctica's ice sheets, these mountains may eventually become exposed for the first time in millions of years, though such an event would signal catastrophic global sea level rise. For now, they remain hidden sentinels of a prehistoric Earth, their peaks reaching toward but never touching the world above. 10th. Unmapped cenote cave systems beneath the Yucatan Peninsula. Beneath the limestone surface of Mexico's Yucatan Peninsula lies a vast network of water-filled caves and tunnels that form one of Earth's most extensive underground river systems. While divers have explored sections of these sunken labyrinths, hydrologists estimate that up to 80% of the region's cenote cave systems remain unmapped and untouched by human presence. These unexplored passages extend for thousands of miles, connecting sinkholes, underground rivers, and caverns in patterns still largely unknown to science. The geology of the Yucatan creates perfect conditions for these hidden waterways. The peninsula consists primarily of porous limestone that gradually dissolves when exposed to slightly acidic rainwater. Over millions of years, this process has hollowed out vast underground networks. When portions of cave ceilings collapse, they create cenotes, natural sinkholes that provide access points to the aquifer below. However, most of the system exists far from these natural entrances, accessible only through narrow, twisting passages that may extend for miles. What keeps these cave systems unexplored is their extreme diving challenges. Many passages require specialized technical cave diving skills and equipment due to their narrow confines, complete darkness, complicated navigation, and the ever-present risk of stirring up silt that can reduce visibility to zero in seconds. The most remote sections would require dive operations lasting many hours, with multiple gas mixtures and underwater habitats. Technical challenges beyond even the most advanced cave diving expeditions currently possible. The unexplored cenote systems hold irreplaceable archaeological treasures. The Maya considered cenotes sacred gateways to the underworld and performed rituals including human sacrifices around these natural wells. Archaeologists have discovered countless artifacts in explored sections, including jade offerings, pottery, and human remains dating back thousands of years. The unexplored regions likely contain perfectly preserved artifacts that could revolutionize our understanding of ancient Mesoamerican civilizations. These untouched cave systems also preserve a unique biological record. Specialized creatures known as stygofauna have evolved in complete isolation within these underground waters. Blind, colorless, and often miniaturized, these animals include species found nowhere else on Earth. Biologists have identified over 30 new species in explored sections, suggesting the unexplored regions likely harbor hundreds more undiscovered life forms, perfectly adapted to this light-free aquatic environment. Beyond their archaeological and biological significance, these unexplored cave systems represent one of Earth's most vulnerable water resources. The entire Yucatan Peninsula depends on this massive aquifer for freshwater, yet the region's rapid development threatens its purity. Without comprehensive mapping of how water flows through these systems, protecting them from contamination becomes increasingly difficult. The challenge of balancing human needs with conservation grows more urgent as tourism and development expand across the region. The technological hurdles to exploring these systems extend beyond diving challenges. Conventional mapping techniques like GPS don't work underground, forcing explorers to rely on methodical survey methods using measuring tapes and compasses, a painfully slow process in such complex environments. Recent advances in underwater drones and 3D mapping may eventually allow remote exploration of passages too dangerous for human divers. But for now, the majority of this vast underground world remains a blank spot on our maps, a wilderness flowing in darkness beneath millions of human feet. From the crushing depths of the ocean to the fiery core of our planet, these unexplored places remind us that Earth still holds mysteries beyond our reach. While technology continues to advance, some places may forever remain untouched by human presence, preserved as the last truly wild frontiers on our planet. Perhaps the most intriguing question isn't where humans haven't been. It's what might happen when we finally reach these places. What ancient life forms, preserved for millions of years in perfect isolation, might we disturb when these sealed worlds finally meet ours? If you enjoyed this video, click on the video on screen to learn more Did You Know facts.